Hello and welcome to AGH Marines video describing our approach to hull design of our AUV Hauler. My name is Tomasz Małachowski. I have bachelor degree in mechatronic engineering and attend master's program in this field. I am the president of AGH Marines and leader of the software team.
My name is Filip Dudek and I have a bachelor's degree in mechatronic engineering and I also attend a master's program in this field. My roles in AGH Marines are the vice president of the organization and also leader of electronic hardware and embedded software team.
My name is Kacper Przybylski, mechatronic engineer, currently studying at AGH University of Science and Technology in Krakow. I am also vice president of AGH Marines and leader of mechanical team.
My name is Andrzej Frączek. I have a bachelor degree in mechatronic engineering. I attend master program in this field. I am a member of the mechanical team and CAD designer.
We all study at AGH University of Science and Technology and also share the responsibility of system engineering of our project.
Main goal to achieve while designing the chassis was to meet our stiffness requirements. Robot of length above 1 meter needs to be as stiff as possible in order to prevent it from any vibrations and deformation caused by thrust force.
Furthermore, the chassis has to be designed to withstand high pressure related to submersion. Also, it is a platform to mount every subsystem of our robot, so it had to be taken into consideration during the design process.
Finally, the chassis should be as light as possible, so we had to work out a proper geometry that provides low weight and maintains previously mentioned durability and stiffness.
In addition, we plan to design and 3D print the bodywork, which will provide extra stability and reduced drag force of the robot. It will be generated by A-class surface modeling, which will help us design the most hydrodynamic body.
The design needs to specify the place for the electronic system enclosure where all of our components will be safely kept and a dedicated battery storage. Both need to be absolutely waterproof, as any leak can damage electronic components or even create dangerous chemicals due to their contact with batteries. As a way of interfacing between external and internal components, such as motors and their controllers, we chose waterproof cable glands with at least IP68 norm because they provide the highest reliability in comparison with their cost. The components inside the electrical enclosure with the highest power consumption need enough space for heatsinks, as they are going to raise the temperature pretty quick, especially in a closed space like that.
Of course, the hull must provide good positions for cameras and other sensors like Doppler velocity log, as these components are vital for simultaneous mapping and localization algorithms. Additionally, the hull should prevent the creation of additional noises and disturbances that may affect DVL and other sensors' data.
In order to not generate too much hydrodynamic drag and for safety reasons, we make sure that all cables have sufficient diameter and can be hidden inside the outer hull. Interior of the electrical enclosure is planned with careful consideration of placement of all the components to provide them with enough space for electrical isolation and air ventilation and direct heatsinks.
The key factor giving our robot advantage over other constructions is hydrodynamic bodywork. State-of-the-art A-class modeling reduces induced drag force, which gives us an opportunity to move faster from one task to another. Reduced drag force positively affects robot's power consumption, thus the overall weight and volume of batteries can be much lower. Moreover, it enhances robot stability while moving in an underwater environment, which could reduce or eliminate robot's regulating system disturbances.
All that effort would not be possible without proper system engineering and team management. We have the mechatronic system approach. Its main practice is to design the whole project simultaneously on every ground. Mechanical, electronical, software and the control system. Parts are developed at the same time with high concentration of communication between teams. This approach shortens time needed to accomplish a project. It also allows for agile development, as the changes can instantaneously be considered and applied. The structure of AGH Marines is flat. Teams are small yet effective, each with its own leader. This allows the team members to stay informed and have a view on overall project status, but to focus strictly on the tasks, which are to be completed before the next milestone. The milestones meeting are performed to summarize the effort and plan the next steps.
In order to verify if we have enough space inside the electrical enclosure, we will create virtual prototypes of all components and PCBs. Then we will 3D print all of them and empirically prove the design's feasibility. This mockup will allow us to check the compatibility of mechanical and electrical subsystems in a cheap way before we commit to supplying and manufacturing all the components.
Virtual prototyping using CAD software helps us design the best possible geometry of the robot. After creating 3D models, every vital part and subsystem is virtually tested by FEM analysis. We conduct mechanical, fluid flow, and heat transfer simulations to be sure our construction is adapted to work in underwater environment. Thanks to the iterative process, we can achieve better results in any aspect of all subsystems. For example, increasing the strength of chassis components and lowering its weight simultaneously. After completing virtual prototyping process, we are going to build a prototype using modern manufacturing techniques, for example, 3D printing. Next, we will validate models and simulations results in reality. For that purpose, we will design and assemble a test stand which will allow us to measure physical data such as speed, thrust force, and drag force generated by Haller.
Thank you very much for your attention. We would like to invite you to our website, which is regularly updated with further information about our AUV project. We will meet again in the second video describing our effort on the subject of propulsion system.